Kalimera. Good morning, ladies and gentlemen. Thank you for giving me this opportunity to make a presentation on this very interesting forum today. The subject of my presentation today is safety aspects on using LNG as a fuel. I will mainly focus on LNG bunkering, which is considered as the most critical operation for this new technology that gets more and more support in the maritime industry. I will start by looking at some major physical and chemical properties of LNG and what makes it actually so special compared to fuel oils. Then we will briefly look at the bunkering station requirements and equipment. Then we will focus a little bit on the bunkering operation, and finally we will summarize with some items that need to be considered in respect to safety. Starting with the properties of the LNG, actually we call it it's a refrigerated gas. LNG comes out from a treatment that the natural gas actually is being treated and then liquefied, and so it comes the LNG, which in order to be kept at the liquid status, it needs to be kept very cool because its boiling point at atmospheric pressure is minus 162 degrees of Celsius. It's of course flammable. The limits are between 4.5% and 15% per volume in air. It's colorless, nearly odorless, non-corrosive, non-toxic, but it can act as an asphyxiant in enclosed spaces. So what is so special about LNG? Of course, the very low temperatures, the cryogenic temperatures that we have in order to store it. And that means that any contact with milled steel, carbon steel, will lead to brittle fractures. Also, any contact with the human skin will lead to the so-called frost bites, as we call it, which means severe burn injuries. In addition to that, LNG is a constantly vaporizing liquid. In order to be kept cool, always some part or at the top of the liquid is being vaporized, and that means that during LNG transferring you have a boil-off being generated, the so-called boil-off gas, and this must be handled as you are not allowed to vent it in the atmosphere. So you need to have some kind of an equipment and of course operations to handle the boil-off gas that's been generated. In addition to that, it is an aging cargo. That means that its composition changes in time. If you keep it for a very long period into a specific tank, then its composition will change. It is flammable, so you need to define some hazardous area around the storage and the piping, and around the tank and the piping, and of course, and finally, its composition, its original composition, depend on the source, so it can vary. In respect to the bunkering station requirements, these are applicable for LNG fuel ships, but also applicable for LNG bunkering ships. So first of all, you need to have sufficient ventilation, either natural or mechanical, gas detection, of course, physical separation and structural protection, deep trays, and etc. Because you don't want to have any cryogenic spills on your carbon steel. Draining, purging, inerting provisions, ESD, emergency shutdown systems, remote control, fire detection and extinguishing systems, and etc. In respect to the components used for the transferring of LNG at the moment, we have either cryogenic composite hoses, mechanical cryogenic arms in the industry, or hybrid systems with hose manipulators. Quick couplings and tri-brake couplings can assure a safe and easy operation, and actually they have become quite a standard for LNG bunkering operations right at the moment. These are all the possible scenarios for transferring LNG on board an LNG fuel ship. Mainly we look at the first three. The fourth one, moving a portable tank, this goes under the IMDG code, the international code for carrying dangerous goods. So mainly all the LNG bunkering guides and guidelines that you will see in the industry, they are mainly focusing on these the three first operations. Let's take a look at a real operation, let's say now for a ship-to-ship transfer, transferring from an LNG bunker vessel on board an LNG fuel vessel. First of all, in any case, it seems that the LNG in the fuel vessel will be at a higher vapor pressure and temperature than the LNG in the bunkering vessel. And this is because, as I said before, when keeping for very long time, the LNG, this is because you have kept for a very long time the LNG into your LNG fuel vessel, more than the LNG bunkering vessel. There is a very possible scenario that the design pressure of the bunkering vessel may be at a lower than the design pressure of the LNG fuel tank in the LNG fuel vessel. So in the case where you connect, except from the liquid line, of course, you may also connect the vapor line in order to connect the vapor space between the tank space, the tanks. That will lead actually to excessive boiling of the LNG in the LNG fuel vessel and overpressure in the bunkering vessel. What we want to highlight on this slide actually is that you need to have personnel and crew, and generally the operator needs to be very well trained and experienced in order to control all the pressures that to control the pressures and do the operation safely. In another case, you may not need to connect the vapor line between the tanks. That means actually that you will most probably reduce the loading rates. However, in this case, both of the vessels need to handle their own boil-off. That means that you need to have the appropriate equipment, and of course, the operators on both the vessels need to be very well trained and experienced. And of course, you need to have very good communication in order to control the pressures in both the sides. So, on a ship-to-ship operation, what are the main issues to be considered? Ship compatibility, transfer system equipment, transfer area, environmental conditions, electrical isolation, and etc. I will have to go a little bit faster. In respect to, but even if you don't do the ship-to-ship operation, or when loading LNG from shore, either from a tank, from a short tank, or from a truck, then again you need to look at several local authorities' requirements, meaning exclusion zones, hazardous areas, what are the simultaneous operations that are that you can do during the bunkering, firefighting requirements, and etc. So there are many issues that need to be considered. There are in the industry right now available many LNG bunkering guidelines. We just look at here just a list of them. While in the international standards level, there is a technical specification that was issued earlier this year that gives a guidance on the requirements, especially in respect to the crew training, their roles and responsibilities, while it also gives some functional requirements for the equipment necessary to be used during the LNG bunkering operation. It covers, as I said before, ship-to-ship, shore-to-ship, and truck-to-ship operations. There is also another committee has been established in ISO level in order to see in more detail about the equipment and create a bunkering standard for criteria on the equipment and the certification. Simultaneous operations, there are a lot of discussions about what are the operations allowed during the LNG bunkering and what can I do in the same time. Actually, this is a case-by-case study. You need to have a study like the SIMOPS assessment, which will identify the operations that potentially can threaten the bunkering operation, and you will then decide whether those operations should be prohibited or can be allowed under specific control conditions. There is not something fixed on this point. It is a case by case. It needs really good at your case specifically. What are the lessons learned from the early adopters? We have already a report by Norway in the IMO describing 2 incidents that have already happened, fortunately without any injury or major failure. We have also, as ABS, we have also made a study in the US, and the lessons learned that we got from the early adopters in US is, first of all, that the adoption of LNG as marine fuel, it is not a part-time job. You need to have a dedicated team that it will look on this issue from the very beginning of your concept. You need to, there's a limited experience in the market at the moment, so you need to use trusted advisors. Proper crew training is of course essential, and you need to start the dialogue with the regulatory bodies from the early beginning. So, summing up, what are the hazards on LNG bunkering? Cryogenic fuel spill, we just discussed, if you have a liquid on the deck, on side cell. Also, pool fires may be a result of that. Personal hazards. Gas release, of course, because it is flammable, is another big issue. And interaction with a loading facility, this is something we shortly described earlier. So generally, the LNG bunkering operation is for sure much more critical than the fuel oil bunkering, and it is potentially more complex than a standard LNG carrier discharge operation. So the understanding of LNG and its associated risk is very important. You need to have your crew very well trained. You need to use experienced people that they understand all the related problems. There is a lack of universally adopted safety measures and etc., but there is a lot of work on that. So we may see in the future some international standards on the operations, so this maybe in the future will be a problem to be solved. And that is all. Thank you.